Finding a parking space can be frustrating, especially in the crowded areas. But what if a smart system could automatically manage parking slots and guide vehicles efficiently? Today, we are building an Arduino smart parking slot system that demonstrates how modern smart parking technologies works. Welcome to RoboxCraft, crafting imagination into reality. At RoboxCraft, we help students learn robotics, IoT, and automation through hands-on project kits designed for real-world learning. This Arduino Smart Parking Slot project uses IR sensors, a servo motor, LED display, and the microcontroller to automate vehicle entry and monitoring parking availability. This system detects vehicles entering and learning the parking area, automatically updates the availability slots count, and control the parking gate without human intervention. This project is ideal for school or college projects, science exhibitions, engineering mini projects, robotics learning, and Arduino beginners. Now let's explore what's inside this RoboxCraft kit. At the top you can see the goodies with some stickers. Then you can see the servo motors which rotates in the precise angle. You can see these cables for the connections of all the components. You can see the two IR sensors which detects the obstacles, comes in front of it and sends signals to the microcontroller. And this is the 12 IC display which is used for showing the data what is transferred by this Arduino UNO. And this Arduino UNO is a microcontroller. You can see these batteries for the power supply to all the components, and you can see the Arduino cable to transfer code to the Arduino UNO. And here is the switch and the breadboard to set all the components here. We are going to make the Arduino smart parking system. For that, we need the Arduino UNO as a microcontroller, where we are going to connect all the components including the display to show the output. And it is the breadboard, and this is the positive rail of the breadboard. These are internally connected, and this is the negative rail of the breadboard. These are all internally connected. And first of all, we need the two jumper wire, that is male to male jumper wire. You can identify this is the male to male jumper wire. First of all, connect the 5 volt from the Arduino UNO to this positive rail, and another pin wire connect with the negative rail. Then after, we need a servo motor. This is the servo motor which rotates in the precise angle that is sent by the Arduino UNO, and it can rotate up to 0 to 180 degree. This is the servo motor, and to connect this servo motor we need 3 male to male wires. This is the male to male wire. In the servo motor, this yellow line is for the signal to operate the servo motor in precise angle, and this red wire is the positive phase, and this brown is for negative. So we are connecting this yellow wire in the D9 of the Arduino UNO, and this is the middle one, the red one is going to connect with the 5 volt in the breadboard. This is the rail of the 5 volt for the breadboard, and this yellow last one is going to connect for the negative. Next, we need 2 IR sensor. This is the IR sensor. Actually, this IR sensor, how it works is, when any obstacle comes in front of this, it gets the signal that something is in front of this. We can minimize the range by rotating this potentiometer, and whenever it detects something, it sends signal to the Arduino UNO, and the Arduino UNO reacts according to the code we have put in it. In order to connect this IR sensor with the components, we need to male to female wire. Here you can see this is male to female wire. We are going to connect this 3 male to female wire with this IR sensor pins. You can see in the IR sensor there are 3 pins, that is VCC, GND, output. Here VCC indicates to give the power. In the VCC we have to connect this to the 5 volt because the IR sensor operates its 5 volt, where GND should connect with the GND. The middle one is the GND. We have to connect this with the GND. Here we are using 2 IR sensor. That's why I'm indicating this IR sensor as a IR sensor 1. So I'm connecting IR sensor 1 to the pin D2. In the Arduino UNO, this is the digital pins. The range is from 0 to 13. So I'm going to connect it to the D2. Likewise, I'm going to connect another IR sensor. I'm indicating this IR sensor as a IR2. Similarly, in order to connect this IR sensor, I have to connect first of all with these pins as earlier we have connected. Similarly, the VCC goes to the 5 volt. The GND, which is the green terminal, that goes to the GND. And the output, this out is work as a signal. This goes to the D3 pin. Now we are going to connect this display. This display has 4 pins. That is GND, VCC, SDA, SCL. Actually, this display is used to show the output in the return form. Here, in order to connect this, same we are going to use the male to female jumper wires. Here, now we are going to connect the phases. The GND will goes to the GND rail in the breadboard. And the VCC goes to the 5 volt in the rail. The SDA will go to the A4 pin. And this SCL will goes to the A5 pin in the Arduino UNO. After the connection, you have to check all the connections twice, and after checking the connections, you have to give the power before uploading the code and see whether components are working or not. Since it is getting light in every components, then it is perfect. Now we are moving to the further step to upload the code inside this Arduino UNO. In order to upload the code, we are using this Arduino UNO cable. We are going to connect this and we're going to connect this to the laptop to upload the code. And we are using the software Arduino IDE to upload the code. Here we are using this 18650 battery with the switch. The connections of 18650 battery should be like this: is the red wire or positive phase should be connected to the VIN in the Arduino UNO. And the GND should be connected to the GND in the Arduino UNO. After the connection, you can turn on the switch and you can see the display, and the cards count is 0 and the free is free. When IR sensor 1 detects, the slot will open, and when vehicles move from IR sensor 2, the vehicle count is 1 and the vehicle is here. And when IR sensor 1 detects and IR sensor 2 also detects, the count is 2 and the vehicle is in, and the free is only 1, you can see in the display. And when the IR sensor is 3 and the count is 3 and the parking is full. Now cars is 3 is 0 and the parking is full. Like that this project works. Thank you from RoboxCraft.